let's get going. So I want to start with a trig graph, and I want to ask in the chat, what type of trig graph is the one that is currently on the screen? Forget about the question for now. I'd like to know in the chat, or if somebody's willing to come online and tell me over audio, what type of trig graph is this? Okay, Mbali and Nasheen, Annie, lots of students are saying it's the sine graph. I would agree. It is the graph y equals sine x. Okay, you are spot on. You can see it starting at 0, going up at about 90, coming down to 180, 270, and 360. Incidentally, this is also why the cast diagram, if you imagine, I've spoken about this in previous lessons, but you can literally see that sine is positive between 0 and 180, so in quadrant 1 and quadrant 2, and sine is negative between 180 and 360, so in these quadrants it's negative. And so just to show you that the cast diagram and trig graphs are related. Now, something else. I want to visualize, on this graph, I want to visualize minus 0.4. Could somebody tell me, what should I do if I want to visualize minus 0.4 on this graph? You can come online, put your hand up and just tell me how you would visualize 0.4. Or negative 0.4 rather. How would you visualize that? Or how would you interpret it, or any ideas?
So I'm a little shy today.
That's all good. So I was thinking, let's go and find negative 0.4 on the axis. So here's a number over here. It goes as high as 1 and as low as -1. So if I count up, I think negative 0.4 would be this line over here. So I'm going to draw. I know it's not perfect, but that line for me represents negative 0.4. Give me a thumbs up if you agree with my interpretation of negative 0.4. Give me a thumbs down if you're like, I don't have a clue what you're talking about. Okay. So we've got a sine graph and we've got a visualization, which is negative 0.4. So now I'm going to make this a trig equation. I'm going to say to you, I want to solve this a trig equation. When is sine of x equal to negative 0.4? And I'm wondering if anybody could make some guesses for the answer, not looking at the question yet, but just based on the visual drawing of this. What do you think the answer, what do you think some of the answers might be for when sine of x equals negative 0.4? Who would like to put their hand up and have a go at this? Like, right, would it be 30? Would it be 50? Would it be 220? Would it be 300? What could it be? So I see some good guesses coming through. So Sino and Annie and Mbali and Zanele, quite a few students are saying somewhere approximately around like 210, 200 itself, 240, something like that. And I think I know where you're getting this. Where else do you think, is that the only answer that you think is relevant for this? Could there be another answer to this? Are there any? Because I think you're right. I think I agree with you on the two, around about 200. But I'm looking at this picture and I'm thinking, look, there might be another answer to this question. So I think that you guys and girls are looking at this point over here as one of your answers, and that looks to me like it is about 210 or 220. I don't know exactly what it is, but you know, it's around there. Where else might there be an answer for this question? Talisa makes an interesting point. Talisa, anybody else? Cynthia? So a couple of students are saying that maybe the answer could be somewhere around 320 or 340 or somewhere around that part of town, 330. I think that's a pretty good guess, because if I look at this point over here and I go up, it looks to me like it would be approx plus minus 330. Now, this is what my visual system is telling me. But let's just try this out and see how close we get. So I want you to type in your calculator. I'm going to take a guess, like the sine of 210. And I want you to type in your calculator sine of 210 and see what you get. And can you put it in the chat what you get for sine of 210? What do you get for the sine of 210? I'm just checking if we're roughly in the right ballpark. So everyone seems to be saying that for the sine of 210, I get about negative 0.5. Now, that's not perfect, but it's close. So I think we're in the right neighborhood. Like we wanted minus 0.4, we've got minus 0.5. We're in the right neighborhood. I want you to do a similar thing. I want you to try 320. Try the sine of 320. And now tell me what you get for that one. Okay, so the sine, if I look at Sino and Benolo, Bianca, a whole bunch of students are saying that it's about minus 0.6 or minus 0.645. And again, it's not the right answer because we needed something that made it a minus 0.4, but I can definitely see that we're almost, like we're near the right answer. Now, give me a thumbs, actually, no, before we do that, I want you to look at the options. There are 4 different options for the question, sine of x equals minus 0.4. And I want you to tell me which of the 4 options you think is the correct one for this question. So A is here, then B, then C, then D. I want you to vote. What do you think the answers to this question are? Get those answers coming in. So I see some B's, I see some C's, I see some A's. So I like it. There's a nice variation in the class. Who would like to come on and explain why they think their answer is correct? And again, I don't really mind if you're wrong or right. It's just your process of explaining to us that helped us. Who would like to maybe offer an explanation for why they think or how they got their answer? Again, we really value, just even if you explain something, it's not about being wrong or right. It's about sharing your thinking. Who's willing to share their thinking on this? How did you get to your A or B or C or anything like that? Okay.
I'd love to hear your voices, guys.
In class, I would have lunch bars, but unfortunately, they don't go through the internet as effectively. Who would like to, again, all I want to know is what your basic guess. Okay. Trigonometry, let's go to you.
Good afternoon, sir.
Hey, how's it going?
I'm good. I used my calculator. I said the answers closest to negative 0.4 are B and C. So
B and C.
Yes, sir. I used my calculator. I said sine negative 24, and I got negative 0.40.
Okay.
So round it off at 0.4. Even C, I got the same answer.
Okay. I'm going to say that the correct answer is C. And the reason the correct answer is C is that thank you so much. That was awesome.
Thank you.
If you look at this equation, the correct answer happens around 200 over here and around 330 over here. And there are two answers. If I look at this domain, so between 0 and 360s, so between 0 and 360, the question actually says this question is only between 0 and 360. There are two places where minus 0.4 cuts the sine graph. And so I know that it can't be B because B only has one answer. I need it to be two answers. And I don't think it's 24 or 156 because those would be in the first part. And there's no way that this red line cuts the blue line in the first quadrant. So my answer would be C. Give me a thumbs up if you kind of understand my thinking there. Give me a thumbs down if you don't understand my thinking. I just want to get a feel for the people of the class. Okay. We're going to do now, I'm going to teach you a method. I'm still trying to help you understand what an answer to a trig equation looks like. The main thing I wanted to point out was that trig equations don't just have one solution. They can have many solutions because that's the first thing. And the second thing is that I wanted to give you a visual sense of how a trig equation can be visualized. Okay, but it's fine. I'm going to do another one like this now. So let us go to this possibility. So again, I've got the sine graph, and the equation is solve for sine of x equals 0.6, and your answer needs to be between 0 and 360. I would like the students of the class to try and answer this question. What do you think the correct answer for this is going to be? I'll give you a little hint. You can put your answer in the chat when you feel like you understand. So if you think of the quadrants, like we spoke about in previous lessons, here's the end of quadrant 1, here's the end of quadrant 2, quadrant 3, quadrant 4. In which quadrants do you think your solutions are going to be in? That's the important thing to think about. I feel like I can eliminate two options. I feel like it can't be B and it can't be D. I think it's a bit harder, though, to distinguish which of the next two are correct. Now, one thing you could do that would be a little bit sneaky is type 36.87 into sine and see if you get 0.6. That would be, I mean, we're just doing a multiple choice question. So if you type sine of 36.87, do you get 0.6? Or the sine of 143.13, do you get 0.6? Or do these other ones over here with C, do they work? So try that, and then I want to see what your final answer would be. Aha. For A, I get both 0.6. Yes. So the correct option for this one is A. Okay, so this is solving a trig equation visually using the visual graph to help you do it. But you can imagine if we solved every trig equation this way, it would take a long time. So what I'm going to do now is I'm going to teach you a method, a foolproof method that will help you solve this. But before I do that, I just want to check that you still remember the cast diagram and you still remember which angles go in which quadrants. So the cast diagram says that cos is positive in quadrant 4 and that all the trig ratios are positive in quadrant 1, that sine is positive in quadrant 2 and that tan is positive in quadrant 3. Give me a thumbs up if you feel very comfortable with that cast diagram idea. Okay, now, I like it. The second thing you need to know to help you solve trig equations is in each quadrant, what form are the angles in each quadrant? So first quadrant, all angles have the form theta or x, depending on what variable you're using. I'm going to use, well, let me use x because the question is in x. So I'll call that x. All angles have the form 180 minus x in quadrant 2. What form will angles have in quadrant 3? All angles in quadrant 3, what form will they have? So Melekiah, Cynthia, Annie, you're quite right. It's 180 plus x. And then in quadrant 4, it will be 360 minus x. Okay. So this is important because if we know what's going to happen is when we solve these equations, at some point, I'm going to ask you what quadrant we're in. And you need to know the form or the structure of an angle in a particular quadrant. It all sounds a little bit weird, but you'll see when I start. So if you want to solve a trig equation, you obviously start with an equation like this. So sine x equals 0.6. That is your equation. So step 1, and I'm going to do it for you, and then the next one, you'll do it. You find your reference angle. Your reference angle you find by ignoring if there's a negative sign. So this one is a positive, so there's no problem. But if it was negative, you would just ignore a negative. And you type in your calculator, shift sine 0.6, or it looks like sine minus 1 of 0.6, and you're going to get an angle. I want to know what that angle is. Pop it in the chat. So go shift sine 0.6, and you're going to get an angle. So I see students are getting 36.87. Okay, now that is only step 1, but it's not too bad. Step 2, I want to ask you, in what quadrants is sine positive? Now remember, when we started this equation, sine of x was positive 0.6. Which quadrants is sine positive in? Okay. And I can see in the chat, things are lighting up. We are definitely getting quadrants 1 and quadrant 2. So in this situation, we have identified there are 2 places where there could be a solution for this equation. The one is in quadrant 1, the other one is in quadrant 2. So the third step, I'm going to write a Roman numeral for 1, and I'm going to write a Roman numeral for 2. These stand for the 2 quadrants. And what we're going to get here is one of my answers is going to be in quadrant 1, I just use the straight angle 36.87. So I get x equals 36.87 plus I write this weird thing that looks like this plus k times 360. And all that does is it tells me that my solution repeats every 360 degrees. I'll talk more about that later. For now, it's just something I add on. In quadrant 2, my answer is going to be, because it's in quadrant 2, so in quadrant 1, it had this format. In quadrant 2, the format I had was 180 minus whatever my reference angle was. And I know the first time you see this, you're going to find this a bit strange, but just go with me on this. You've got a reference angle. And for quadrant 2, you can't just leave it like that. You must change it into the form 180 minus the reference angle. So we go 180 minus 36.87 plus k times 360. And then what we're going to do is we add on a little symbol that looks like this. I'll explain what that means later. Now, using your calculators, I want you to help me find what is 180 minus 36.87. Okay, 143.13. I see lots of 143.13. Okay, now, if you look at my answers here, using this process, the one answer is 36.87, which is what I got over here. And then my other answer is 143.13, which I got over here. Those are the two answers in 0 to 360. And then this K times 360 business is just saying that I can get additional answers by adding 360 or subtracting 360 from it. But for this first round, I just want to make sure that the general structure, you kind of can see my three-step process. Give me a thumbs up if you understand the steps. I'm not saying you can do them, but you understand the basic steps that I've just showed you. Okay. Now I'm going to do another example for you, and I want you to watch carefully. And then after the break, you will do it by yourself. But I'm going to do one more before the break, and then we'll go from there. Okay, take a screenshot if you want of this process. It's a three-step process. And let me go to an example over here. So in this one, I'm going to choose to do this question over here. And what's a little bit tricky about this one is that it actually is a negative. So my three-step process says, I want to find my reference angle. But when I do that, I'm going to go shift sign or sign -1, but I'm going to ignore the negative. And this is important. So I ignore the negative and I go shift sign 0.327. Can someone do that on their calculator and tell me what that is? So you go shift sign or inverse sign 0.327. What value do you get for your for that? So Nosheen has, Melakaya has put an answer in there. So there's a couple of 19.8 or 19.09. I haven't got a calculator with me right now, but I'm going to take it as 19.09 just for now. But we must be careful of our rounding. Okay. Then in step 2, I want to ask you, what quadrants is sign negative in? In what quadrant is sign negative in? I look at Joy, Annie, Melakaya, Awam, Bali, and Zanet. So everyone is saying quadrant 3 and 4. So we do have to round off our answers to two decimal places normally, yes. In quadrant 3, I'm just going to call it plus theta because it's less confusing that way. These are the two. The theta is just the reference angle. Okay, so this thing over here is just the reference angle. So I know that my answer will have this format. Okay, actually, let me not call it theta. Let me call it x because I was using that before. Plus x minus x. But this is just the reference angle. Then step 3 is to say theta, because that's what I'm trying to find, is equal to 180 plus 19.09. Notice that that is just the reference angle that we found, and I'm using this format of 180 plus because I'm in quadrant 3. Plus k times 360, that is the one answer. Oh, I forgot to write my Roman numerals. Sorry, guys and girls. I think I'm just going too fast. Now for quadrant 4, I'm going to get theta equals 360 minus 19.09 plus k times 360. And then I do that. Now to get my final answer, I'm going to get 199.09. I'll come back and answer that question right now. Can somebody work out what this bit is here? 360 minus 19.09. I need that to get my second answer. So I'm going to get 340.91 plus k times 360, where k is an element of z. Okay, now there's a couple of questions in the chat that I want to reply to. The first one is, why are we using quadrant 3 and quadrant 4? Why do we use it? So the reason we are going plus and minus is, where is sign negative? Now, the very original question said, this is the original question. It said sign was negative, which means my answers had to be in quadrant 3 and quadrant 4. But in order to get these, I first have to find my reference angle. And to do that, I ignore the negative. The negative is taken care of by choosing the correct quadrant. If I was dealing with negatives here and here, I'd be taking the negatives into account too many times. So all we do is we make it simple. We find a reference angle, we know what quadrant we're in, and then we get our answer by using the structure of that quadrant. But another question is, what is this k times 360 thing? Now, the k times 360 thing is just saying that these solutions repeat every 360 degrees. So the way I can show you this is the answers so far that you've got are 199.09 and 340.91. But if I added another 360 to this, so take 199.09 and add 360, what do you get? Someone can tell me in the chat. So what's 199.09 plus 360? Okay. So Melika and Talisa have all said 559.09. Now, if this truly is also an answer, it should get us back to, basically, it should give us almost the answer at the top here. So I want everyone to do this. I want you to type in your calculator the sign of 199.09 and check that you do get very close to minus 0.327. I also want you to type the sign of 340.91 and check that you get very, very close to this number. And then I also want you to try 559.09, check that that also gives you. I'm trying to show you that the answers I'm getting are true. So Kamogelo, you should be in degrees, not radians. So if you are getting that, if you're seeing that those three numbers are close to your answer, it means that the method is working well. So Sino has said all answers are true, and he says perfect, fantastic. Now, this is my magic method for solving trig equations for general solutions. And I promise you guys and girls, once you get this, it's marks in the bag. Okay. So we will do more of these after the break, but I've really pushed you hard now, and I think it's important that we all just take a break. So that's awesome. So let's do that. I want everyone to stand up like this happy chappy over here, and I will join you in a second. So away from your chairs, your brain has worked hard, you need to take care of it. And turn your cameras on so I can see you out there, out in cyberspace. Oh, and just give your arms a bit of a swing so that they are, some of that tension from all that thinking can just melt away. There we go. Swing those arms, swing those arms. And now,
turn on your cameras to see your lovely faces.
I really like seeing my students in the house. I feel like a real teacher then. Okay, then let's do some circles like this, small circles, and then slightly bigger circles. And then eventually you are winding it around nicely. Oh, doesn't that feel good? All that shoulder tension just melting away. Then let's stretch it out like this. And let's switch to the other side. Okay, and then let's roll the shoulders back. And let's roll them forward. Okay, and then one last shake just to see that everything is loose and stuff. And then we are going to do a high heart rate activity, and we're going to do our firm favorite, which are jumping jacks. Make sure no one's nearby so that you don't whack anyone in the face. Make sure you're away from your desk and any glasses, etc. And we're going to do, let's start with 10 and we might go a bit further. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 5 more. 1, 2, 3, 4, 5. And your body hopefully now is feeling like it is a bit more grounded.
Alive.
And a bit more alive. And all I'm going to do now for our brain break today is I'm going to ask you to try and find 24 using these 4 numbers. So you have to use each number once. Have we done this one before? I don't think so. But you need to try and make 24 using these 4 numbers. And you may use plus, minus, times, and divide. And yeah, that is the way. Let's see if you can do it. What do we think? Who would like to tell us how to do it? Maybe somebody can come on the line and tell us how they would do it.
Share your secrets.
Yeah. Okay, I see a hand. Whose hand is that? Massimo,
Massimila.
let's go to you. What do you think? What would you do? Can you hear me?
Well, so the first thing I did, the first thing I did was I minus 7. Yes. So
7. I think I heard minus 1, which I agree with. So 7 minus.
Yeah, I minused by 4. Yes, 7 minus 1 in a bracket times 4.
Aha, 7
Yes,
minus 1 over brackets times 4, and that actually gets you 24, but you still have one more 1
yeah,
to use.
times 1. Times 1.
Sneaky, yes. Absolutely. To you goes the glory. Well done. That was a good one. And I see quite a few students in the chat have worked that one out as well. So just in case you're new, we play this game where we try and take the 4 numbers to make 24. And depending on the day and how much time we have, sometimes we do a red one, sometimes we do a blue one. But for today, I'm just going to stay with that because I think that's enough to have our brains have a break. So let's go back to this world of trig equations. And I want you guys to find the general solution for number 2. So I want you to solve the trig equation cos of theta equals 0.231. I'll leave the previous question on the screen if that is helpful to you. Otherwise, I encourage you to ask questions. See if you can find the general solution to this trig equation. Off we go. And remember, there's 3 steps that you can use. And while you start on that, I will. So what is my reference angle going to be? Put that in the chat for me first. So 76.64. I think that looks good to me. Now, what quadrants is cos positive in? If you think of the cast diagram, which quadrants? So I think it's going to be quadrant 1 and quadrant 4. And I'm thinking of another, instead of writing 108, I could also write this as this is the reference angle and this is 360 minus the reference angle in this quadrant, if that's easier. I don't know if that's easier or harder for you, but there's no doubt that quadrant 1 and quadrant 4 are going to have solutions in it. So how am I going to write those solutions out? I want to give a bit more time for students to think about this. But I know it's going to be theta equals and theta equals. Okay, so I still did that quite quickly, but my final answers are 76.64 and 283.36. The K times 360 is just saying that these answers can repeat every 360 degrees. So if I add 360 or take away 360 or add 720, it'll still be an answer. But my answers are in quadrant 1 and 4. And if you want to check if this works, you can even just type cos of 76.64. In fact, let's do that. Type cos of 76.64, see that you do get 0.231, and type cos of 283.36, and then just give me a thumbs up if those answers are making sense for you. Okay. Awesome. All right. Now, I'm seeing lots of thumbs up, which is good news for all of us. I want to try doing number 5. But number 5 is a little bit tricky initially. There's one thing we have to do before we can get started. And I'd love for somebody in the class to put their hand up and maybe make some suggestions. Because when we solve the trig equation number 5, it just looks a bit different. So I'm wondering, can someone help me spot why it looks different?
We
So
have a
Sino
hand
has a
from
suggestion,
Cynthia.
and Cynthia, let's go to Cynthia. Cynthia, what do you
Afternoon, sir.
think? Hey,
There is a number in front
yes,
of cos.
yes, and that causes things to get a bit more tricky, doesn't it?
Yeah.
How would you get out of this problem? What would you suggest we should do?
I think we should divide by 5 both sides.
I think you are a problem solver. You are quite correct. So I want everyone to solve this equation. The cos of theta equals -2/5. And the tip that we've got from Cynthia has put us on the right track. So I feel like I'm ready to hand it over to you. Please solve that trig equation for me as a general solution. And Puleng agrees, I see. And Sino agrees, Mbali agrees. Chigavatso agrees, Annie agrees. Okay, so lots of students think that moving 5 over will be a good idea. Okay, what's my reference angle going to be? Okay, now, important thing you have to do is you have to ignore the negative. This is really important. You ignore the negative and you should get 66.42. Now, what is the second step? In which quadrants is cos negative? Notice how we take care of the negative now. We don't take care of the negative in the first step. We take care of the negative when we see which quadrants is cos negative in. So we are handling the negative. We're just handling it in a different way. So we are in quadrant. So Bonolo has asked, why do we ignore it first? Bonolo, it's just easier if we think about the quadrants telling us where things are positive or negative. And if we have to deal with an angle being negative as a reference angle, and we have to deal with the issue of which quadrant it's positive or negative, it just makes it much more likely that we make a silly mistake. So the reference angle is just trying to find the acute angle solution to the question, but then knowing the real solution is about making sure we're in the right quadrant. I'll maybe try and explain it in a bit more detail at the beginning of the next lesson, because I don't want to go too deep right now, but trust me, from the amount of times I've done these, I can tell you this method is a lot more reliable. And so it's worth just getting used to it. So 180 minus the reference angle for that quadrant, and then it would be 180 plus the reference angle for that quadrant. And the answers would be in quadrant 2 and quadrant 3 is what I'm seeing. And because the variable was theta, we'll say theta minus, or sorry, theta equals or and in case you're wondering what this funny thing is, it's a Z with an extra line, and it means it's an integer. So what is my final answer going to be? It's going to be 113 point. Now there's some variation here, but it looks like 113.58 plus k times 360, or theta was equal to 242.62 plus And so those will be my solutions. This is the general solution to the trig equation. The cos of theta equals minus 2/5. And just to bring it back to the beginning of the lesson, when I started showing you the graphs, if you think of the cos graph, right? The cos graph goes as high as 1 and as low as -1. And if we had to imagine the different quadrants being visualized on a thing, I think you all know that the cos graph looks something like this. Now, this equation is saying where is the cos of theta equal to minus 2/5, or about minus 2 point, that's about minus 0.4. If you imagine where that would be, okay, that would be somewhere over here. And so you can see that the two solutions that you're figuring out are about correct. This one over here would probably be the 113. And this one over here would probably be about the 242. And so I just wanted to come back to that as we finish tonight, and you don't have to worry about the graph right now. I'm just trying to build you understanding that the graphical world and this method tell you the same story. Oh, did I make a mistake? Sorry, I flipped it around. You're right. I made a mistake. It's 246 point. You're quite right. It's 246.42. Thank you for everyone for popping that up. So this should be about 246 approximately. Yes, you guys, I'm super impressed. You have picked up on that straight away, which shows me you understand this very deeply. So I just want to I know I've done a lot today, but can we have a quick vote? Thumbs up if you feel like you understand this process. You definitely need to practice it more. And a thumbs down if you're a bit still quite unsure. Just want to get a good feel for how people are feeling. Because again, because we on the internet, there are some advantages, but there are also some disadvantages where we can't always see exactly students' faces. So for those students who are feeling a bit confused, what I'm going to suggest is you go after the recording is released, you re-watch this part of the lesson again, and just see if the second time you watch it, it feels a bit better. Okay? So the second time you see it, it probably will make a lot more sense. Okay. And I will talk a little bit more about this in the next lesson next week before we start trig identities. Lebel, could you put the link to the quiz in the chat? That would be awesome. So everyone, that is it for tonight. I think you've done really well on the whole. And give it a go. The quiz today deals with co-ratios, which is the lesson that we did on Monday, and it deals with trig equations, which we did now. And so, don't worry, Annie, we are going to, by the time you get your June exams, you are going to be ready to rock and roll. And the reality is, Annie, that your exams in term 2 are a much more accurate reflection of your understanding than at the end of this term. So don't worry, you will get there. Okay. Cool. Are there any other questions? Otherwise, has Lebel shared the link yet? Or maybe Lebel, I don't know if Lebel's had some issues. Maybe she has. Let me go and see if I can find the link for you from Slack, and I'll pop it in a moment. So let me go to live classes and foundations. There we go. And then I will pop it in here is the link to the quiz. And yeah, enjoy it the rest of the week, everyone. I hope you enjoyed the lesson. And have I sent the link to everyone yet? Nope. Hearties has finished it already. You are on fire. Okay, awesome. I'm glad you enjoyed it. And I will try and put the link now to the quiz. I think Lebel may have got struck by load shedding. There is the link. Look at me multitasking. All right. Yeah. Awesome, everyone. There's a question I see from Inga. Let's go to Inga. Bye, Talisa.
Hello, sir.
Hey, how's it going?
I'm good. How are you, sir?
Very good. What can I do for you?
It's based on question 5, sir.
Yes, go ahead.
I wanted to know how is it in the second and the third quadrant, sir? When
Okay,
it comes to
why-
cos.
Yes. The reason it's in the second or third quadrant, are you familiar with the cast diagram? Have you heard of this thing called the cast diagram? Okay, now,
Yes, sir.
in this question, cos is negative because cos theta equals -2/5. Now,
Yes, sir.
cos is positive in these two quadrants, but those aren't the quadrants you want. You want where it's negative, and it's negative in quadrant 2 and quadrant 3.
Okay, sir.
That's why I draw the 2 and the 3 to tell me what quadrant I'm solving in.
Okay, I think I understand now. So it's all of the signs. Didn't see the signs, sir.
Perfect. Thanks
Thank
for the
you so
question.
much, sir.
Pleasure. Bye, Peleng. Bye, Mbali.